Okay, I think we're ready to go. We need another couple of minutes for people to show up anyway. Good morning. My name is Mark Gill. I run the visualization and the AI and visualization lab down in the College of Science and Engineering, located in the iSelf building on the first floor. If I'm there, anybody's welcome to visit, stop by, and see what kind of stuff we're doing. Today, I am talking specifically about image and video generation using AI, and maybe not the kind that you may have been exposed to. So when anybody talks about using artificial intelligence to generate some sort of imagery or some sort of video, there's a range, right? There's an entire iceberg of different tools that we have available to us. A lot of us may be familiar with ChatGPT because it's very popular in our news feeds these days. You know, oh, here I am as Studio Ghibli or an anime character or whatever, right? You just tell ChatGPT what you want and it generates an image. Midjourney is another one where I just tell it what I want and it generates an image. It's very good. Gemini does the same thing. And some of these are getting really powerful. Like I can say, generate an image of me, and then generate an image of me wearing a nice suit, generate an image of a dog, and generate an image of this dog sleeping on the couch. It'll do stuff like that. It's really cool. As you get deeper and deeper into this iceberg, they get deeper and deeper barriers to entry, right? So, you know, some of these are free up at the top. ChatGPT or Gemini will give you some free usage, some free availability. As you get deeper and deeper, then you have to start doing stuff like paying for Photoshop. But Photoshop also provides you a greater depth of the type of tools that you have available. As we get deeper into this iceberg, we start getting into video capabilities. The price starts going up. If you want to, Google has what is considered to be one of the best commercially available video models on the market, called VO2. If you use it through Google, you're going to pay 50 cents per second to generate video, right? So if you're doing any kind of serious work, well, if you're doing any kind of really serious work, it may not be the tool for you. But if you are, it's probably going to be very expensive. 50 cents a minute, it's going to rack up. What I'm going to be talking about today is completely open source, completely free. The only thing you pay for is time and kilowatt hours. And we're also going to be swimming really deep on this iceberg. So as I was talking about before, DALL-E 3, Google Gemini, I can walk up to it and I can say, give me a picture of an anthropomorphized turtle sitting at a table working on a laptop, and they will do that in a coffee shop. And these are really good if you come up with a prompt like this that you can try over and over and see what the different flavor, the images that you get from these different AIs. There's going to be a sameness to all of them. And one of the things that I'm going to do during this is explain where that sameness comes from. DALL-E is going to give me very similar sort of plastic colored sort of images. Gemini at least gives me a little bit more realism, but I can still tell from the way the highlights are falling across different objects, the way it's doing the shading. If you look at enough of these, you'll be able to pick out, oh, this was done with ChatGPT, this was done with Gemini. Subtle differences, but also these differences are consistent from image to image across the models that these things generate. We're going to be talking specifically about diffusion models, which operate a little bit differently from what you may think of as a large language model, which is a language transformer. A large language model, by contrast, just predicts what the next token is. Now, it's got a pretty complex order of tokens that it's trying to put together. But it does just predict what the next word is and completes word sequences until it gets a complete document done. Whether that document is a recipe or a piece of code or a Shakespearean sonnet or whatever, they all work about the same way. Diffusion models work a little bit differently. They work on the pixel level instead of, say, the syllable word level like other language models. So it's adjusting the color of individual pixels until it resolves something that it thinks equates to the prompt that it's got. When you train these models, you also train them differently. Training involves taking an image. So here's my dog Cooper, and I tell the model, this is my dog Cooper. I describe it however I would expect the user to be able to describe it, and then it just keeps adding noise to it. This is still my dog. This is still my dog. This is still my dog, until the noise completely obscures the entire image. So it starts from a fully resolved image and it keeps adding noise and adding noise and adding noise until there's no dog left. And then you get the reverse out of it. You start with a random noised image and say, now draw me a dog, now draw me a dog, now draw me a dog. And step after step after step, it cyclically goes through this noisy image, adjusting the colors of individual pixels until it gets what it thinks is a dog, or whatever the prompt is, a dog sitting on a bed, whatever you have. And that's sort of the workflow of a diffusion model. Now, when we're talking about, and this is going to be important later on, you'll see the power of this next thing. For a computer, there's really no difference between, or not much of a difference between an image and a video. So if I can think of an image as like a 2D arrangement of pixels, like on a screen or in a window or a file, a video is a 3D arrangement of pixels. And it still trains on the same sort of diffusion structure, except the video model is thinking of a 3D image, and the image model is thinking of just a single slice out of that. What that means is that a lot of the tools that we use to manipulate images can also be used to manipulate videos. So yeah?
Are you taking questions now or later?
And questions anytime.
So
in fact, if you guys are sick of this, we can talk about something.
No. So isn't it the diffusion model structure that allows for embedding elements into images that aren't noticeable to the human eye, but that can mess with the model distribution in a public safety way is what I'm thinking.
Can you give me an example?
So let me do some checking and I'll be back to you. But I do think that it was something about the way the transformer works that you can embed like encrypted things and code. Would that make sense for a diffusion model? Or
yeah. I mean, I can take any sort of imagery. So here's an example. I'm going to steal some of Rosemary's thunder. Probably more than once over this. Her students, I'm going to talk about what her students did with Roko. They trained a local model to produce art in their own distinctive style. One of the students had several images that looked like 35 millimeter film strip. They had the little holes, the perforations on the side, and even the little light bar that does the audio on the film strip. Anybody, if you remember 35 millimeter films, that's how they did audio in the early days, was there'd be a strip of light or white bars, and that represented the audio. So the projector would actually look at that and translate that into sound. That was in a lot of the images that one of the students put into the training data that they used to train the model. So, I don't know, a lot. How many would you say, percentage-wise? How many pictures came out with those?
Large amount,
large amount.
Pretty much most images you would generate would have some kind of
film strip on it. And it would put it all over, right? Sometimes it would put it around. Sometimes it would put it like across the middle. Sometimes it would say if it were doing a soldier, it might be on his uniform or something, right? But yeah, so you could do stuff like that. If I put those things into the model, it can show up all over the place. So there are limitations to a diffusion model, right? They're not as well. They're really big because working with an image can be a big chunk of data, right? 24 by 768. You do the math. Each one of those has got 32 bits. It's a lot of bits, right? So it's so they're relatively large chunks of data. And the models, especially the models that we're working with on this box, have been what they call distilled down into its essential elements. So it's got just enough smarts to do some basic stuff, but it doesn't know a whole lot, right? Like if I say, I want an apple, it'll give me an apple. And if I say, give me an apple sitting on the counter, the apple that it puts on the counter is probably going to be the same apple that it gave me before. And every time it gives me an apple, it's probably going to be the same apple because it's really only got one apple. It knows a basic apple. But if I say, give me a Fuji apple, give me a Granny Smith apple, right? It's just going to give me an apple. It's probably going to give me the same apple. So there's limitations to what these models are going to be able to do. And that's where a lot of this sameness comes from. It gives me the same college student. It gives me the same car. It gives me the same whatever you're trying to get out of it. That's because it just doesn't have very many college students and cars in its base model. It knows a lot about generating images. It just doesn't have a lot to work with when it's coming to generating those images. There's also a lack of control over the process if you're using diffusion models that are available through something like ChatGPT or Midjourney, right? I have a couple of options. I can try to talk to ChatGPT and ask it really nice, and there's some prompting games that I can play with it to get different styles out of it, but I still don't have a lot of fine control over the model or the image that I'm generating. And then both video and image, if I'm asking for a really big image or I'm asking it to work really long, if I'm trying to do a video that's longer than a certain length, then model drift is going to be a problem. And that's where a lot of people that refer to AI jank or AI slop or whatever, that weird sort of nightmare fuel, third eye coming out of the side of their head, right? That's coming from model drift. Over time, the model forgets the prompt. It forgets the context of what it's working in. So the longer these things go, the more off they start off the rails, right? they go off the rails almost immediately. Most of them do. And it's the longer I let it go, the more disastrous that result is going to get. Also, longer works take up more video RAM. VRAM is a specific type of memory that computer systems have. This system over here that we call Roko has 30 some odd gigs of video RAM just on the video card, and that's what these models want. They don't really care how much system RAM you have to a point, but they really want a lot of video RAM on that card. So that's another one of the limiting factors. And speaking of Roko, this is Roko over there. So Roko has a 60-core Xeon, which is a lot more processor than this thing needs. This would be a good processor for a server, but we don't have enough hardware on the other aspects of this to serve out more than one. All of these things are network enabled. So you notice everything that I'm doing is running in a browser. Mario.
I'm curious, could you have a render lab? Could you connect multiple computers with that system?
No, it's a different type of thing. Yeah, you're thinking of like a 3D model or like Blender or Max or something like that, right? I could.
Because we have a render lab with about 500 computers on.
Yeah, they'd each have to be big enough to hold the model, and then I'd have to have some sort of central agent that could break it up into frames and say, you render this frame, you render this frame, you render that frame. It's possible. In theory. I wish I lived in theory. Everything works there. So Roko has 64 gigs of RAM, plenty of RAM. The secret sauce is the NVIDIA Quadro RTX 5000. So it's not your average gaming card. It's awkwardly named like most NVIDIA cards are. So it's got a total of what the system thinks is 60 gigabytes of video RAM. So it's large enough to hold a really large model. I can get a large language model on here of considerable size. Any kind of model that we can put together ourselves will run on it that will fit within that video RAM space. We have plans to use it for data processing and fine tuning other models to suit other needs. But for the past few weeks, for most of the semester, it's been used for videos, well, not videos, but for artistic rendering, artistic images based on the work of Rosemary Williams students. Now, there's a lot of benefits about using a system like Roko, but I just realized that I have a slide dedicated entirely to that later on. So I will skip over that for now. Flux is, well, we have two image models on Roko right now. And they are Flux and HyDream. Now, Flux has been around a little bit longer. It's almost a year old. It generates really fast. There's a huge community of people that are writing additions to it, writing modules for it, writing things I don't want to talk about too much because I also have slides dedicated to those here in a little bit. And this Flux was the model that Rosemary's class used. Now, another one that came out like a week and a half ago, 2 weeks ago, HyDream. It's brand new. It's also running on Roko, but it has superior prompt adherence. And I'll give you an example of the kind of prompt adherence it's got. So this Roko over here, I just generated this image with Blizzard and this hockey player. And I don't know if this is big enough, if that's big enough for you guys to see the prompt that I used for that. But I described both characters in the image. So, and this is something kind of new that I could say, here's character A, this is what character A is wearing. Here's character B, this is what character B is wearing. This is the environment, this is the camera settings. Character A and character B are doing these things. A fairly elaborate prompt for an image generator. But the thing about HyDream is it's using an entire large language model to interpret the prompt. A lot of these other ones have a tiny little neural network in them that takes your prompt and turns it into tokens really quick, but really doesn't do a whole lot of interpretation on it or doesn't try to understand anything about the context of it. HyDream has got Llama 3.1 running in it, actually inside of it to do its text interpretation before it gets to the image. So you can give it really complicated prompts, and it's going to be able to sort those out and interpret that into something that the image generator is going to be able to use. I've done it with 3 different characters. I'm not sure how many characters, or I could have like 2 characters in a group. Maybe the group is doing something. But the addition of a full-fledged large language model to do the image interpretation really adds a whole lot. The only thing I'm waiting for now is for the community tools that have been written for Flux that allow us to do a lot of really cool things with Flux. I'm waiting for those things to be written for HyDream, or I'm trying to figure out how to write them myself. That's really want to do is I really want to write the tools that we need to extend HyDream, because right now HyDream is that base model. It doesn't know a whole lot. It's got a Apple, it's got a college student, it's got a car in it, right? But we have ways that we can give it all of the apples, all of the college students. I'm really getting ahead of myself here. So. And then on video, and I forgot to get a nice little picture from my video. The 2 video models, well, I don't have Juan on here yet, but we have Juan 2.1 and FramePack that just came out. Juan 2.1 has been around for a couple of months, so there's community support. There's people that are writing extensions for it. It is a very powerful and capable image generator. It does some really good work. You still get a little bit of jank in the fingers, but it's only limited to like 8 seconds. So I really can't do more than an 8-second clip with it. It's really good at adhering to like action prompts. So if I wanted to do somebody dancing, say, or kung fu fighting, if I want everybody kung fu fighting, do what? Everybody kung fu fighting. Then one is sort of like fine-tuned for that. FramePack solves another one of the problems that we've had. In fact, FramePack is kind of revolutionary in image video generators. Pretty soon we may see this approach that FramePack takes to all sorts of stuff.
Are those tools all free?
Yes. Everything I'm talking about today is free and open source.
So you can install it in your own, any kind of computer.
Yeah. If you got a video card. It takes much video card to do this. FramePack will run on a 3070 though. FramePack does a couple of different things. FramePack can play around with how much video RAM it uses. So it could trade out video RAM for execution time. So even if I've got like a mid-level video card or a mid-level gaming PC, FramePack will fit on it. FramePack will run on anything better than a 3070. May take you longer, but you'll still be able to generate 2-minute video clips with it, which is the other thing that FramePack does. Every other video generator, all of the ones that are popular, Google's VO2, Sora, Kling, Runway, the list goes, every one of them that's come out that's been new and sparkly for the past 2 years has had a limit of between 5 and 10 seconds because of the video drift that we talked about earlier. The longer it goes, the more it starts going off the rails almost immediately, and the longer it goes, the more off the rails it gets. But FramePack has an interesting way of going through and sort of reminding itself periodically, and it actually starts from the end and works its way forward, so it figures out what the last frame needs to look like, and it works its way back towards the front frame. But whatever it's doing allows it to generate up to 2-minute clips. Now, why would you need a 2-minute clip? In most videos, right, we're talking 5 to 10 seconds on average, maybe for most clips, unless you're Quentin Tarantino or something. You got some really, but
commercial.
Right. Well, with FramePack, I can generate 2 minutes of the AI doing something. Somewhere in that 2 minutes, I've probably got 15 or 20 usable seconds of content. Right. It still goes off the rail every once in a while. In fact, I started it up a while ago. Come back. And you're getting a little preview of the video that it's generating. So it's already done 30 seconds of a 45-second video clip that I've asked it to do. It may get done by the time I'm done here. Roko does a second of video generation in about 4.5 minutes. So, and I could get that second of video generation for 50 cents on Google though. But Roko doesn't charge me 50 cents a second. So the tools that we have on a system like Roko, there's different workflows, different ways that we can work with. Text to image, where I give it, here's my prompt, generate the image. It's probably the least control that I have over something, but I can use image to image, where I have a reference image and I say, here's the image I want you to work with and I want you to change it. Or I want you to take this image and put this image inside of this other image. That would be in painting, where I in-paint some other object into either an image that I'm generating or another existing image. Out painting is where I zoom out and I paint around the borders of the image and sort of just make it bigger and use the AI to make sure that the new border imagery matches up with what I have inside, which it pretty much just leaves alone. We have the similar sort of features with video control. So I can do text to video, where I just give the video a text prompt and let it generate a video. I can also say, here's an image. I want to use this image as the first frame of my clip. Quite frequently, that's the workflow. It's a workflow that I did with this. So if I'm generating a video, I generate the first frame of the image with something like High Dream, which is what I did the Blizzard and a hockey skater. And I took that over to FramePack and said, here's the first image of my clip. here's what these people in this image are doing. Give me 45 seconds of that. So we'll see what 45 seconds of that looks like here in a second. So being able to generate half a minute, 2 minutes, right? This is somewhat revolutionary. We're going to see, I bet all of the video models start adapting themselves. Or actually, what I think is going to happen is it'll just be a module that I plug into whatever video model I happen to be using. Which brings me to Comfy UI. Comfy UI is the interface that we've been working with this semester. Rosemary's students have just gotten it all over them. It's a messy looking interface, or it can be a messy looking interface, but it's a powerful interface. And power, versatility, and complexity, they all go hand in hand. Right. So if I've got something that's going to enable me to do anything, it's going to be kind of hard for me to work with. There's going to be a lot of complexity to it, but I'll have complete control over that thing. Every node in a Comfy UI structure is a little block of Python code. So if I really, really wanted to, I could dig into the Comfy structure and I could write new modules myself that add new functionality to Comfy just based on my own particular needs. So as during the development of a project, we could say, wow, it'd be really nice if we could write this thing so it would be able to do X, Y, and Z. Well, you get in there and you write your Python script, you plug it in, and off you go. Should be a little more complicated than that. That's right at the top of that Dunning-Kruger sort of curve. How hard can it be, right? But it's also open source. It's rapidly updating. There's a huge community of people using Comfy UI. And I was wondering the other day, where's Comfy UI's, what is their business plan? If they're giving everything away, how are they making money? Turns out, virtual machines. So there's several companies out there. There's Mimic PC, Comfy UI itself online has a bunch of virtual machines. And Comfy UI is selling virtual machines that already have whatever workflow you want configured in it. So if you tell it, I want to be able to do X, Y, and Z, then you fire up your virtual machine, and maybe you've got something with a lot more horsepower than Roko. I think it's $1.50 an hour to get an A100, which is a large rack-mounted GPU. But that's where they're making their money, is by providing interfaces for virtual machines. And I'm pretty sure Comfy is a ironic name. I don't find it to be particularly comfortable. And here's a, I apologize. Not everybody was in the room when I said this earlier. This is going to be sort of a technical discussion, but I don't expect anybody to absorb any of that technical discussion. I want to impress on people that this is an instrument, not a tool. So when, and this is typical for both an image workflow and a video workflow. Clip is the language interpreter, right? So in the case of HiDream, Llama 3.1 is their clip. It's what it's being used to interpret images based on, or to interpret the text and translate that into something that the imagery can use. VAE is also another tiny little neural network that translates pixels into tokens, or tokens into pixels, and tokens being the lifeblood of the artificial intelligence. It's the language that it's thinking in. It's not really a semantic thing that we understand. It's just numbers. But VAE is what takes those tokens and turns them into imagery, or takes imagery and turns them into tokens. The model is the actual thing that's doing the work. LoRa's or low rank adapters that modify how the model works, and then maybe some sort of latent image if I want to give it something to work with, or maybe just an empty image that it can start generating stuff from. Clip takes the prompt. Sometimes I have a positive prompt. This is the stuff I want. Sometimes I have a negative prompt. This is what I don't want. The VAE can encode my image input, and then all of that goes into a sampler that actually goes through the steps of adjusting the pixels step by step until it gets to what it thinks the person is looking for. Oh man, I got plenty of time. We'll probably do some hands-on stuff. And then the VAE decode is reversed. That process is reversed. So I take the mass of tokens that's been generated by this, turn it into an image or a video, and then I output it. This is dramatically oversimplified. For every one of these steps, I could be plugging in other modules that enhance or extend each one of these different features. So here's an example of what I could do with a reference image. So there's a picture of me on the left, and then in fact, so here's the workflow that I had to generate that. Let me come back to this. So this first one is I wanted to make it to look like an 1880s sort of daguerreotype sort of photo. And in order to get that to work, I actually had to plug in another module to desaturate my reference image. And then I wanted to make myself look like I was carved out of wood and with red stain on my face, and that worked out fairly well. And you're thinking to yourself, Mark, this is so lame, because I could do this on ChatGPT. ChatGPT will do this all day long. You know, what's the big deal? So what the big deal is, I have absolute control over what it does, how it's doing it, and so many different variables and so many different parameters to change exactly what it is that I'm trying to get. So here's some different attempts at doing different reference images based on my original picture, make myself into a cartoon. Then at the end, I was working on melted ice cream. Melted ice cream wasn't working out very well. And then I said, well, I try to mongify this wedding photo here.
And this is comfy.
This is comfy. It is very comfy. Let me get back over here to comfy. So here's all of those different modules that I was talking about. Here's where I load Llama 3, load the model. I have my positive prompt and my negative prompt here. I don't do much with the negative prompt. Sometimes it makes a difference, sometimes it doesn't. The sampler over here is where all the work is done. I tell it how many times I'm going to let it iterate as it's working on something. I tell it how much I want it to adhere to my prompt, which in an instance like this is sort of a balancing act between my prompt and my reference image, because in a way they're sort of competing with each other. I can tell it how much I want it to adhere to my reference image, how much do I want it to adhere to my prompt, how many times do I want it to go through this? And eventually I will get something that is balanced in what I'm looking for. They call this point of something or other. I had the name for it. It's a sweet spot. It's a point of synchronicity, of syncope, where my parameters and my inputs just sort of happen to converge at exactly the thing that I'm looking for. If I let it go too long, I'm going to get something weird. If I don't let it go long enough, I'm going to get something weird. If my parameters are out of whack, I'm going to get something weird. So the difference between a system like this and a system like ChatGPT or Gemini is that somebody over at OpenAI has gone through the trouble of figuring out exactly what those parameters are, how long to let it run, how much to adhere to the prompt, so that most times I get exactly that sweet spot, or what it considers to be a sweet spot. Because where that sweet spot is a completely subjective thing. It's entirely up to the person that's using the hardware as to where that sweet spot is that I'm even aiming for. That's where a lot of the sameness from, say, the images that I get out of ChatGPT or Midjourney is because somebody else has done all that for me. They've decided where that sweet spot needs to be. They've decided what the parameters are and what those weights are, so that when I type whatever in, I get something out that is going to hit that sweet spot that somebody over in San Francisco or something decided that's where it needs to be. I don't control the sweet spot in that. I don't define the parameters, and I don't have any control over exactly the look and feel of what I'm trying to do. The difference is I put together a workflow like this and I'm using just the default values. I may be so far away from that sweet spot, and it's going to take me some time to sort of hone in on exactly that range that I'm looking for. So there's and I've said it a bunch of times. I'm sure a lot of people in here have heard me say this. This is not a tool. This is an instrument. This requires practice. This requires a lot of experimentation, because the downside of this is there's not a lot of documentation. I don't know who wrote half of these modules. It may be somebody who just said, hey, here's a useful piece of Python code. It got dropped into the code base. But it seems to be working. The code to do the color correction on my reference model. It seems to be working for me. So carrying on. Does anybody got any questions at this point?
What's the training data from?
So,
Precision picture.
so a lot of the training data comes from, now if you're talking about the actual imagery that goes into the base model, there's a pile of model data on Hugging Face called the stack. And that's where a lot of people draw from the imagery to get their base model going. Now that will result in a model that's too big to fit on something like Roko. So a lot of times what they'll do is they'll take that base model and they'll, in a process they call distillation, they'll take out a lot of the just generic information that may be in it. So let's say in the stack there's 100 different pictures of dragons, right? So if I train on that, conceivably it's got a wide variety of different dragon ornaments and art structures and anatomy that it can draw from and mix and match and whatever. But we take a lot of that out, except maybe for just one dragon. And so it knows if I tell it to draw a dragon, that dragon's going to look pretty much the same every time. But that's what they have to do to make it small enough to fit on a single box like this, is take out a lot of that information. So, and then everything else you have to give it, which is what I'm getting to in a second. Does that answer your question? Okay. Was there another question? Okay. And we're not standing on ceremony here. If anybody's got a question, feel free to step into it. So reference images are one way that we can control what happens, what the output of the model is. Another very powerful way is through something called control nets. So a control net is a completely different type of process. A control net is I give it a reference image or I give it a reference video, and the control net can trace out the edges. This is what they call a canny effect. I'm not sure where the name canny comes from, but where it's looking at all of the individual edges. It's also got a depth effect where it can look at the depth of the input image and figure out how close different things are to the camera or far away from the camera. And the imagery that it puts out is based on that depth. Then it can also judge the pose. Let me move that thing. It can also judge the pose of the character, find where the face is, find where the body is, find where the arms and the limbs are, and use that to drive the pose of another character in a generation. So here's an example I was using. I think this was all done with Canny, right? So this was my original image, and I say, okay, give me this woman made of ice, made of wood, made of marble. And this is just one of the applications that you can do with it, where it can take the structure of the image or the pose of the character and then translate into practically any other style. I'm using this to inform the AI where I want it to start when it's doing its work. So here's one that I did earlier. And you notice the workflow has gotten a little more complicated. This entire block over here is intended to describe how I'm capturing this information. So I've got this video of this guy walking, and then these modules over here. This one is calculating the pose, so I can see the pose of the character as he moves along. This one is calculating the depth. Over here, I have a reference image that I'm using. And then the whole thing gets combined together where I can take my reference image and have it put into pretty much any scene that I want. Now, what's interesting is no matter how I define the imagery that I want this video to be generated in, it's always going to have these benches. This character is always going to be here doing this same sort of motion because these benches are in the depth over here. So it doesn't really know that they're benches. It's just there are bench-shaped things over here in the preview video. So it's going to put the benches and the other stuff in there as it goes along.
Could you, like going back to depth, could you isolate just the part of them walking? Or would you be able to do that?
I don't know. I know with the pose, I can isolate. I mean, and I'm blending the two of them together. I don't have to do that. I could just take the pose, but then there wouldn't be anything to inform the background or anything to inform really that he's moving. Yeah, I don't get I want to say the answer to your question is yes, provisionally. I just don't know how to do it because I can take this and I can break this up into different layers, and I can put these elements on different layers if I wanted to. In fact, I'm doing a little bit of that with the compositing to get these two back together.
But you would have to have it moving no matter what you did.
Yeah.
Because it's the context that matters, right?
Yeah. So my input prompt on this one was: a man with a gray beard wearing a nice dark casual suit walks along a path in a park on a beautiful college campus on a sunny spring day. And everything that I generate is going to be something more or less along those lines. One thing I did find out this morning is that the aspect ratio of the reference image needs to match the aspect ratio of your video clip. So if you want to do a video of yourself or your dog or a raw uncooked chicken doing the Macarena, you're going to want them both to be in the TikTok orientation in order for that to translate well. Another sort of
I'm inspired by the chicken. I'm just saying.
the chicken.
Yeah.
I only say that because I've seen one. A chicken. Yeah. And what's weird, the first frame. Watch it. The first frame. It's going to be a picture of my reference image. So I guess that is something else that I need to look for, is find some way to trim the first frame off of this. And this one I started off the same way, but with a different reference image, because this is how I see myself on the inside. And it generated that. Roko generates something like this. Anywhere between 10 and 20 minutes. This process over here can take about 10 minutes for it to do, but it only has to do it once. If I don't change any of these parameters, I don't change out the video, then this only has to be done once, the first generation will be 20 minutes, and then every generation after that will be about half that time.
What's with the light on the bottoms of his feet when he walks? Just asking.
That is AI jank. He walked through a puddle of AI jank.
Okay.
I'm not saying these are perfect or really, very good. Because I'm not the person that this tool is intended for, right? I'm the person that puts this tool together, and then I need an artist to come in and sit down with this and learn the tool and learn the process and actually put the thought and the creativity into what do I want to do what do I want my reference image to be? What do I want my video to be? Right? I don't have that skill set. I can put the workflow together. This is something I'm starting to understand. I don't want to say I understand it yet. But it is definitely something that I'm really taking a liking to, at least working with it.
Is that particular system taking a hold in the gaming industry too?
In terms of using Comfy UI for like game programming?
Or video generation, for example, or things like that.
Oh man, Microsoft and NVIDIA both have plans for full AI generated games, where all of the interaction, all of the characters, all of the entire world is completely AI generated. I saw where they had if you sign into Xbox Live you can play Doom 2 or no Quake 2 in a tiny little 320 by 240 window, but it is also completely AI generated. All of the actions, all of the video, it is taking one frame of that image, and based on your keyboard inputs, it's figuring out what the next frame of that video needs to look like with an image model, just based on your keyboard, and it runs at like I think it's 15 frames a second. So small video, bad frame rate. That's as bad as it's also as bad as it's ever going to get. It's only going to improve from there. One thing about it though is it doesn't have any object permanence. So like if you're shooting an enemy and they're just too much for you, you can just turn your back on them and wait like a second, and when you turn back, they'll be gone. So wish life worked like that. That'd be awesome.
No, it's you were kidding. So is this the future of AI generation, do you think, in terms of the model creation and the workflow that you've got here?
It's certainly part of it. It's certainly part of it. I think there's always going to be a spectrum, right? There's always going to be tools up at the top of the pyramid where, oh, I just want a picture of my hamburger, right? Yeah. Type it in, right? Oh, here's I just want something quick. I just want something, I can make a funny little meme out of, so I can put it on Facebook, get a couple of yucks out of it, and never think about it again, right? Okay, those tools are always going to be there. They're always going to be high level. They're always going to be self-contained and individual little packets of worthlessness for the most part, right? But they're going to be good for that. And then we're always going to have this lower level control where you can literally do anything. It's not the end of the project. It's not the end of the workflow. It's the beginning of the workflow. This is what the results that you get out of something like this is what you take and incorporate into the rest of your production. Another thing that we can do with these, while we're talking about how we get the most out of this, and this is what Rosemary's students were working on, is training a low rank adapter. Right? And this is probably one of the most powerful levels of control that we have, especially when we start combining it with these other modes. So if I take, say, a LoRA and I combine it with a reference image and I combine it with a control net, now I have the entire suite of capabilities of controlling what the final output looks like for my video, whether or not it's an image or whether or not it's a video or whether or not it's coming in on different layers or something like that. But it also is a pretty complicated process. LoRa stands for low rank adapters. And I can think of, yes.
Do the biggies use any of those tools in the background?
I figure they have to, or something analogous to it.
Correct. It's just more the beefed up.
Right. They're
More
beefed
trimmed
up.
version of what you get.
Right. And all the parameters are preset. Right. So I don't.
Do any of the what?
The biggies.
Biggies.
The biggies.
Not ChatGPT.
ChatGPT, the big cloud-based stuff. So a low rank adapter, you can think of it as more. You can think of it as more model. It's more neural network. It's more neurons. It's more information for the model, and it has to be built in the same structure as the model. So every one of these models has a different vocabulary that you need to know the vocabulary before I can start training new data to go into the model. So LoRa's, because I can give it whatever I want it to train on, they could be used to come to understand different artistic styles, or I could have a LoRa that is trained on a particular character, which if I'm doing, let's say I'm doing something that's got some sense of narrative to it, where I have characters that I want really defined in terms of the clothes they wear, the way they look, the way their face is set up, whether or not they've got tattoos, all of the details about that character, I want to remain consistent from generation to generation. That's really hard to do unless I have something like a LoRa. A LoRa can define this character, right? Let's say I give a character, I call it, I don't know, Angie, right? And I define Angie. I take a bunch of pictures of Angie. They could be any style. They could be photos. They could be comics. They could be cartoons. They could be 3D models. They could be Lego blocks. It doesn't really matter. I get a bunch of pictures of Angie. I tell the model, hey, here's Angie sitting in a chair. Here's Angie standing in front of the camera. Here's Angie climbing some stairs. Here's Angie getting out of a car. I generate all of those images, and then I train the model on it, and then I can produce images of Angie doing just about anything. So I take a handful of circumstances, I train the model on that, and I get a much wider availability of things that I can do with that. I can also do things like correct for bias in the model. So a lot of people talk about, or it's becoming quite popular to talk about how I can't get a model to draw something holding something in their left hand. They just don't do it. And you can sit there and you can engineer prompts and you can go back and forth with it. And you're just not going to be able to get it to draw anything in the left hand. I can correct for that with a LoRa by giving it pictures of people holding things in their left hand. The reason it can't do it, it's just missing pictures of people holding something in their left hand. All the bias comes from the model data, which probably comes from the internet, which probably comes from our culture, which believes that left-handed people are all evil. So we don't take pictures of left-handed people because they'll break our cameras. I'm kidding. No offense to any left-handed people in the audience. I have left-handed my friends myself. But I can fix that. Some of these models don't like to draw full glasses of wine because all of the pictures you see of a glass of wine are only half full. So it won't draw a picture of a glass of wine filled to the brim. I can do stuff like I can take the SESU logos and all of the different official branding and get it exactly right. And I can train that up in a LoRa, and then I can put it on whatever I want. Put it on the wall, put it on a glass, put it on a t-shirt, whatever. I can also train a LoRa to have specific types of motion. So some of these video models, it's very hard to move the camera. The camera likes to stay stock and look at whatever it's looking at. Controlling the camera motion, positioning the cameras, that is something else. That's an extended ability that I could give the model through a LoRa. So having a LoRa solves a lot of the problems that we have just using the base model. I can train it on my information, in my style, on the material that I want it to work with, in the way that I want it to work with, and basically make my own new model out of that, which is really, that's also possible. But that's the next step is we take all of this information that we have been putting into LoRa's, and we can put it right into the model and make our own new model. Mm-hmm. And then that makes working with it a lot easier because I just have to load the model. I don't have to wire other LoRa's and stuff into it. I just used the model because it's trained on the stuff that I wanted to use. I'm almost out of time here. I thought I had plenty of time, so I rambled on about some other stuff. I'm not going to say too much about ART 353 because quite a few of them are in here. And in fact, Rosemary has the podium immediately after I do. But they took, it was a couple of generations. We did 2 or 3 different LoRa's. We did one that was just a throwaway. It turned out to be garbage, but we learned so much from doing that the next one worked really well, which was, like I was talking about earlier, a SESU branding LoRa, where we took the C logo and just a handful of images of that and trained Flux to be able to put the St. C accurately on just whatever we want. It even puts a little registered trademark in there, although sometimes it's not an R. Hey, I'm just saying. But her students had to gather the material, they had to curate their own material, they had to describe the material, set up the training data, which the training data for a LoRa is a picture and a description, The description needs to be the prompt that I would expect to get this image out of. So we learned a lot about curating material. We learned a lot about writing descriptions. We learned a lot about how to fix the training software when it breaks, because the software that I found for training Flux was remarkably delicate. Like, don't touch anything or it'll clear out and we'll lose 4 hours worth of work, which happened once. Was that 4 hours of work? 6 or 8 hours worth of work. Yeah. Yeah.
Brutal.
So I actually wrote a script that will go through, after they get the stuff into the training material, it'll go through the training data and fix any sort of ASCII encoding errors, which is what caused it to crash the first time. So that was interesting. In the end, though, I think I learned more than anybody else in the room. I learned so much about how to break a LoRa, how to fix a LoRa, how to use a LoRa. Didn't really pick up a lot of art, but that's not what I was there for. I personally, I feel like this is the most important thing that was done in the Viz Lab this semester. In terms of student engagement, in terms of getting technology into the hands of the students, which is really the mission, right? Other schools in the system have a computer like this, and they're using it for all faculty-facing stuff. They're using it for, class planning, course prep, grading, that sort of stuff, and it's all faculty usage of the system like this. And I think it's more important to get this equipment in the hands of the students, regardless of whether or not we're doing something with art or if we're doing something with data processing or meteorology or, whatever the use case happens to be. It needs to be students that are using these computers. And I think that is, yes?
What did you use? It seems to be a lot of different things come into play into one.
Yeah.
Here to here to here to here to here to here. So, the beauty of AI is you have kind of a simplified version of all of this. You type something in and then you can maybe modify it. But where did you get the information from? Was it through Comfy UI that said you can use this? That's a lot of different parts. I think it was 10 or 12 different modules. Easily.
So Comfy UI has a lot of examples. The documentation is not very complete and it's in Chinese. So it's kind of hard to follow, but they have some good examples. I've also made a career out of reverse engineering obscure or not very well documented software. And there's a lot of that. There's a lot of, well, what does this do? I don't know. Change the number, see what it does. And writing scripts to, maybe the number that I'm interested in, the parameter has, a range of 0 to 100. So I write a script to, okay, I'll generate it at 5, generate it at 10, generate it at 15, generate it at 20, see what that does. There's a lot of that goes on. Especially when you look at the vast number of models that can be plugged in, parameters that can be plugged in, things that can be swapped out. And yeah, that's how I do it. It's there's not, apparently there's not a lot of documentation. Now, what I expect to see happen, over time, these things, functionality gets encapsulated and gets elevated to another layer. I would expect to see another layer appear on top of Comfy that has got a lot of sort of pre-programmed or pre-configured sets of modules that I can just sort of drop in, and I don't have to wire each individual node together. In that case, that would be nice.
We need to, given the size of the group, I'm not sure how many people are going to be staying for some of the student presentations. You're please welcome to, but we need to transition into the auditorium. So we need to take a little bit of break so we can get set up in there, and then continue.
Okay, I got like one more minute.
Yep.
Okay, so Roko smooths over what I consider to be a host of ethical hard edges, right? The model that is on it is so small that it practically has no other base model information in it. Almost all of the material that's being used to generate the stuff is things that we have to provide ourselves. So it's our work, it's our information, we configure it the way that we want it, and we completely control the whole system. It is also completely sequestered. In fact, if you notice, Roko's not even plugged into the network. He's running completely offline. So the work of the students never leaves the box. It never goes to a cloud. It never gets used to be trained on some other model. And in fact, once we've trained up whatever we're going to be training on Roko, we don't need that imagery anymore. We can take it off the box. So that's one point that I want to make sure everybody understands. The stuff that we're doing on Roko is ethically sourced, free-range data. Right? You can just taste the ethics in it. It's an instrument. It's not a tool, right? It's not something that's going to make your email better. It's not something that's going to make little improvements in your lives. This is something that a dedicated professional would spend all day, every day working with, right? This is going to become a workflow in professional productions, and you're going to need somebody that's going to be able to do it. A lot of people are thinking, boy, AI is going to take all our jobs. Somebody's just going to be able to push a button and they're going to be able to produce anything. No, they're not. Your boss is not going to be able to do this, right? The barista at the coffee shop is not going to be able to do this. This is going to be the work of a trained professional, and it's going to be an artist doing it. That's my take. Also, this level of familiarity with artificial intelligence, this is what employers are looking for, right? Employers are looking for people that can take an AI apart, work with it on this level, and understand how it works at this level to be able to produce anything that they want. Okay, that's pretty much the same thing, talking about how badass Roko is. Okay, here's the end of my presentation. Take it away, Bob.
We're going to be moving into the